Unbelievable. Before our eyes is the Raptor 3, the latest and most powerful version in the world of modern rocket engines. Yet you're not mistaken, and it's not a 3D rendering. It's truly cleaner and neater than we can imagine. So, what has SpaceX and Elon Musk just revealed about this technological marvel? Could there be a new Raptor 3X variant? When will we see this new Raptor in action, and on which Starship prototype will it be equipped? Let's find out this and more on today's episode of Alpha Tech. Thanks for joining us. Indeed, information about the Raptor 3 is not new to rocket enthusiasts like you and me. However, it's only now that we have our first look at the appearance of this engine. On August 3rd, Elon unexpectedly posted an image of a sleek, glossy black Raptor engine that was so clean that most of us thought it was something made in Photoshop. With the tweet Raptor 3 SN1 along with the number 1 printed on the engine, we can conclude that this is the first completed engine of the new generation. While the space community was buzzing with discussion, shortly after, SpaceX's official page confirmed once again with images of the Raptor engines placed side by side, along with a summary of key specs for each type, demonstrating the development of the Raptor through different versions. Furthermore, the company, through precise figures, has affirmed that the research and testing of the new engine have yielded some solid results, and once they publicly unveil Raptor 3, they'll start mass production to quickly proceed with testing. In the announcement for the launch of the new engine, Elon also mentioned significant improvements of the highly powerful Raptor 3. Firstly, one of the main areas of improvement in the Raptor 3 is the reduction in induced mass. Elon stated, "Important to note that the induced mass required by a given engine design, that is not the engine itself, of Raptor 3, while far better than Raptor 2, still has a lot more room for improvement." Elon Musk specifically points out that while progress has been made compared to Raptor 2, there's still some significant room for improvement. Induced mass is a term that refers to all the additional components required to support and integrate the engine beyond the engine itself. These include structural supports, plumbing, and other ancillary systems. Minimizing induced mass is critical because it allows for greater payload capacity, improves the rocket's overall efficiency, and enables more of the vehicle's mass to be allocated for fuel or payload. By using figures provided by SpaceX, we can calculate the induced mass of the Raptor 1, 2, and 3 by subtracting engine mass from the engine plus vehicle side commodities and hardware mass. Therefore, the induced mass of Raptor 1 is 1,548 kilos, the induced mass of Raptor 2, 1,245 kilos, and finally, induced mass of Raptor 3, 195 kilos. Oh my goodness, it is unbelievable that this number has gone down so much. And let me remind you, the number is the mass of the additional components of the engine, not including the engine itself. You can see that most of the flanges and distribution pipes on the first version of Raptor 3 are greatly being simplified, and it also doesn't require any thermal or fire shielding. As such, induced mass of Raptor 3 has been cut by over 87% compared to induced mass of Raptor 1, showing us the absolute refinement and streamlining of the Raptor engine. Awesome job, SpaceX engineers. Raptor 3 has a thrust of 280 tons, more than 20% higher than Raptor 2, and its total mass has almost been halved. Incredible. For comparison, the engine closest to the Raptor that uses a staged combustion cycle with methane and oxygen is the BE-4 engine, which produces about 250 tons of thrust. The special Raptor 3 surpasses popular rocket engines like the RS-25 with 190 tons and the RD-180 with 2 combustion chambers. But Elon is not satisfied with that and also gave us even more impressive thrust of the Raptor 3X. It's expected to deliver over 300 metric tons, approximately 3,000 kilonewtons of thrust, with the thrust-to-weight ratio exceeding 200. Whoa! This means that for every unit of engine mass, Raptor 3 generates 200 units of thrust. Such a high thrust-to-weight ratio enhances rocket performance by providing more power without increasing engine mass. The ultimate goal is to get to 10,000 tons of thrust at liftoff, a level critical for heavy lift missions and deep space exploration. Specific impulse (ISP) is another area where the Raptor 3 shows promise. The Raptor 3 has a specific impulse of 350 seconds, which is higher than that of Raptor 2 at 347 seconds and greater than the BE-4 engine by Blue Origin at 310 seconds and the RD-180 at 311 seconds. However, with Elon Musk's goal for the Raptor 3, X anticipates an increase of ISP of up to 5 seconds over time. While this might seem small, the world of rocketry, such an improvement can have big impacts. ISP is a critical measure of rocket engine efficiency, expressed in seconds. It represents the thrust produced per unit of propellant flow rate, effectively measuring how 1 kilo of propellant can produce 1 newton of thrust. Perhaps most intriguingly, Elon stated that the Raptor 3 is getting close to the limit of known physics. This implies the engine's pushing the boundaries of current propulsion technology in several key areas. That's material science, developing materials that can withstand the extreme temperatures and pressures inside the engine. Combustion efficiency, that's optimizing the fuel oxidizer mixture and combustion process to extract maximum energy. Cooling systems, managing the high temperatures generated during operation without compromising performance. And nozzle design, optimizing the expansion ratio and shape for max thrust in various atmospheric conditions. After all, we can see that the launch of the Raptor 3 is not enough, so there's now the Raptor 3X. And while Raptor 3X is still an impressive improvement for the future, the current Raptor 3 is already the most powerful engine in the world. I am really looking forward to seeing many Raptor 3 engines installed on a Starship prototype, possibly Starship V2 variants currently under construction, because according to slides released back in April, Starship V3 is going to have a booster with a thrust of up to 10,000 tons. And that aligns more with what Elon's been suggesting for Raptor 3X beyond Raptor 3. What do you think about this? Let us know down there in the comments. We'd love to hear from you. And while you're there, don't forget to give us a like and subscribe to our channel. And thanks again for checking us out. All right, back into it. To achieve these achievements, Raptor engine has undergone a series of continuous improvements and iteration, showcasing the company's commitment to pushing boundaries of rocket engine tech. With each iteration, the Raptor engine has evolved, becoming more powerful and efficient than ever before. Since its debut in 2016, Raptor 1 engine has served as a testing ground for SpaceX's innovative concepts. The successful test firings of the Raptor 1 marked a significant milestone in the advancement of rocket engine technology. Building on this foundation, SpaceX introduced the Raptor 2 engine in 2020, which boasted enhanced thrust and chamber pressure, leading to improved efficiency. The pinnacle is Raptor 3, which has garnered significant attention and anticipation. This latest version represents a huge step forward in engine development and showcases advancements in performance, efficiency, and overall capability. With Raptor 3, SpaceX aims to achieve even higher thrust and reliability, pushing the limits of what's possible in rocket propulsion. There's bound to be a ton of speculation about the future of Raptor engine iterations, especially whether Raptor 3 is a temporary replacement for Raptor 2, and we don't have too much info on SpaceX's long-term plans. But I can guess that perhaps Raptor 3 serves as a transitional phase, and that allows SpaceX to gather valuable data and insights while simultaneously working on further refinements of the engine. This means that there are even more insane new Raptor variants like the Raptor 3X that Elon mentioned, or Raptor 4, or even the Raptor 5. Don't forget, SpaceX always has a different approach to the development of engines or rockets than other companies out there. They're always focused on rapid iteration and continuous improvement forward. So it's not uncommon for the company to introduce intermediate versions of their engines before reaching a final optimized design. This iterative process allows SpaceX to test new concepts, identify areas for enhancement, and refine their engines to achieve optimal performance. However, the path to innovation is not without its challenges. The development of the Raptor engine has not been without occasional setbacks and engine failures. SpaceX acknowledges that engine testing is a complex and demanding process, and sometimes engines may fail during testings, either inadvertently or intentionally. Despite the challenges, SpaceX remains steadfast in their commitment to advancing the Raptor engine. The company understands that these setbacks are just a necessary part of the journey towards creating a more efficient and high-thrust engine. SpaceX has addressed key aspects of the engine's design to ensure Raptor in even the harshest conditions of space travel. Through extensive research and development, SpaceX has identified and integrated advanced materials that can withstand the rigors of space travel. These materials contribute to the engine's robustness and structural integrity, allowing it to perform optimally even under immense stress and pressure. Simplification of the engine's design is also a crucial element that contributes to its reliability. SpaceX has pursued a philosophy of refining and simplifying the Raptor engine, reducing the complexity of its components and streamlining manufacturing processes. If we can delete and integrate enough secondary structure, small fiddly bits, then we can protect, rest, and delete engine heat shields, Elon replied to a journalist. That's why Raptor 3's got that clean look we see. However, in my guess, this job is not easy. It requires undertaking meticulous engineering and thorough testing to ensure the engine's reliability and safety under various conditions. Overall, the ability of the Raptor engines to still break their own records in the future is a key factor driving SpaceX's ambitious plans for space technology. With its increased performance and endurance, Raptor 3 engine brings SpaceX closer than ever to realizing its vision of sending humans to Mars. It's poised to power the Starship spacecraft, SpaceX's next-gen vehicle designed for missions to space. SpaceX ensures that the Raptor engines are not just technological marvels, but also practical tools used for space travel. The production scalability and reusability of the Raptor engines make them a key enabler of SpaceX's ambitious plans. In broader terms, the introduction of the Raptor 3 engine signifies SpaceX's commitment to pushing the boundaries of what's possible in space travel. Its enhanced capabilities, including higher thrust and chamber pressure, enable space rockets to achieve higher speeds and carry heavier payloads. As humanity takes its first step towards becoming a multiplanetary species, the Raptor 3 engine stands as a symbol of innovation and a catalyst for unlocking the extraordinary potential of space travel. Elon Musk is an absolutely ambitious man. To supply enough batteries for Tesla cars, he opened 2 huge battery factories in Nevada and New York in consecutive years. And now he's building a second Raptor factory in Central Texas, which will be the world's most advanced, not only specializing in rocket engines, but also making new parts for the Starship spacecraft. What's inside the revealed new mass production factory of SpaceX? This will surely amaze you and even NASA. If anyone loves and studies SpaceX, they know that all the ambitions for the company's rocket programs are not small. From Falcon 9 to now, it's Starship. Honestly, Starship alone is a bold idea, standing out with its ability to be fully reusable while cutting launch costs, promising to change how humanity views space science. However, for SpaceX and Elon, this is not enough. Besides the technical advantages of their rockets, they are also aiming to mass-produce Starship rockets, not just a few dozen Starships, but we can imagine thousands of Starships getting produced like cars. To realize this ambition, upgrading production facilities is essential. In late 2022, SpaceX began construction on its largest rocket manufacturing plant at Starbase named Star Factory. To date, the exterior of the new factory is 80% complete. But what about on the inside? This has been a question among SpaceX fans for quite a while. Fortunately, recently, through an interview by Everyday Astronaut, a famous YouTuber with Elon, we had the chance to see most of what exists inside SpaceX's brand new factory. Entering the factory, we can see a very large space, giving the impression that if you walk, you'll never finish. The factory structure seems quite simple with only a few machines so far, as it's not yet fully completed. When asked when this system will be operational, Elon didn't hesitate to declare,
this will be filled with equipment in 3 months.
Since the video was filmed in early June, this means the system will be operational by October. But that's just the beginning. According to Elon, Star Factory has the potential to expand further to the south of the production area, creating more space for their revolutionary production system. Previously, Jesse Anderson, SpaceX's Falcon Structures manufacturing engineering manager, revealed the latest phase of the factory currently under construction will come online this summer, giving us several 100,000 more square feet of space. This makes Star Factory one of the first commercial spaceports in the world dedicated to a single vehicle, in this case, the Starship. Once completed, the company's goal for this facility will be to produce 1 super large Starship rocket per day here. When you step into the factory, it is truly inspirational. My heart jumps out of my chest, Kate Tice, manager of SpaceX's Quality Systems Engineering, said during the same live stream. Now this will enable us to increase our production rate significantly as we build toward our long-term goal of producing 1 ship per day and coming off the production line soon, Starship version 2. During the visit to Star Factory, Elon shared some astonishing numbers about the production capabilities, particularly focusing on Starship. He revealed SpaceX's initial goal is to produce a ship every 3 days. This means SpaceX aims to create over 100 ships a year in the coming years. While I didn't mention Super Heavy, specifically, I believe its production rate will be similar to, if not greater than, that of Starship. Looking at further goals, Elon previously mentioned his ambition to make up to 300 ships a year. But his latest revelation is even more mind blowing. He said, long term, we'll probably be making 1,000 ships a year. This means production speed would shift from a ship every 3 days to 3 ships every day. Insane, right? Just think about it. Compare this to how long it takes NASA, Blue Origin, or ULA to create a complete SLS, New Glenn, or Vulcan prototype. It takes years. Not only will hardware production soar, but engine production's also set to skyrocket. SpaceX currently makes one Raptor engine every day. Recently, Elon responded to a tweet about the tour videos saying, "We could build a lot more, but the next version of Raptor is really the one to scale up to production. We begin testing it in McGregor within a week or so." Wow! This means Star Factory will enable even more engines to be made daily. This new version could be the Raptor 3. Increasing production rates is crucial as the frequency of launches will rise dramatically, possibly reaching thousands per year to support Mars colonization. Additionally, the draft EIS for Starship in Florida revealed that the new Starship version will feature up to 35 engines in Super Heavy and 9 engines in the ship, further driving the demand for engines. To achieve this, Star Factory will also feature distinct architectural upgrades. First, the new system offers an expansive space, as I mentioned earlier. Estimates suggest the total area of Star Factory will reach 60,000 square meters with an 18-meter height. The flat roof structure optimizes the internal workspace. It is far superior to the old dome-shaped tents, which couldn't optimize workspace and struggled to house large components. These large parts often had to be taken outside the tent, exposing them to weather conditions. Meanwhile, Star Factory is a closed structure, ensuring work inside remains unaffected by the weather, the mud, or the animals. This always maintains a clean environment, just as Elon described. Everything's clean in this. There's no mud and dust. Everything used to have mud and dust, and yes, and birds and things. The most important innovation that Star Factory introduces is a seamless structure, unlike the separate systems of previous tents. With the old separately designed tents, each tent was responsible for producing a specific part of the Starship, such as the engines, rings, domes, or nose cones. This meant the production process could not be continuous. But the most crucial factor will still be the manufacturing technology. The current production process still has many manual steps, such as welding or bending, resulting in a relatively slow pace. Star Factory combines everything into one cohesive unit. This eliminates the need to move between structures, streamlining production steps and boosting efficiency. Elon provided further insights into this transformation. He explained that a continuous production line would create a working rhythm or cadence. Stations will be arranged in a linear adjacent flow model with many stations on the line. While the new system eliminates the separation of steps, it remains highly specialized. Each station will focus on its specific task, but the steps will move seamlessly from one station to the next with equal workloads and time durations. This interconnected flow means problems can be spotted and fixed immediately without the delays caused by moving between distant structures. Star Factory's innovative design promises to revolutionize production, making it more efficient and responsive than ever before. Moreover, Star Factory's manufacturing technology will incorporate Tesla's manufacturing technology into its rocket production process. Manual steps will be reduced and all processes will gradually get automated. This advantage has been demonstrated by the increasing car production output of Tesla each year. Although rocket production is a bit more challenging than cars, and Starship will not achieve output levels equivalent to cars, adopting new manufacturing technology is still essential. With a new production line, SpaceX can produce enough rockets for future launch needs. All this proves Elon is very serious about settling on Mars. It's not a joke. It's not a con for more government money, although Musk won't turn that down. No, Mars is the reason for SpaceX. And now, in South Texas, Elon's getting close enough to Mars that he can almost taste the red dirt. Let's take a moment to truly grasp the sheer magnitude of this endeavor. Starship, serving as the upper stage for SpaceX's Super Heavy rocket, is arguably the most groundbreaking spacecraft ever made. No one has ever achieved a fully reusable rocket before, and the second stage, which ventures into space, poses the biggest challenge. While SpaceX still has a long way to go in terms of making the interior of Starship habitable for human travel to Mars, even the creation of a fully reusable vehicle capable of lifting 150 tons into low Earth orbit would be an extraordinary feat. This payload capacity surpasses that of the Saturn V rocket used in the Apollo 5 program. More impressively, Elon wants to build one of these every week. Compare that to NASA and its space launch system, the big rocket that the space agency has been developing for a decade. NASA will, in fact, toss each SLS core stage into the ocean after a single use. And Boeing doesn't have to make the engines, as the rocket uses 40-year-old space shuttle main engines. Despite this, and with nearly $2 billion in annual funding from NASA, Boeing's stretch goal for building core stages is 1 to 2 per year, sometime in the mid-2020s. SpaceX's stretch goal is to build 1 to 2 Starships every week this year and to pare back construction costs to as low as $2 million each. No, it's absolutely mad, I agree, Musk said. This conventional space paradigm does not apply to what we're doing here. We're trying to build a massive fleet to make Mars habitable, to make life multiplanetary. I think we need probably on that order of 1,000 ships, and each of those ships would have more payload than the Saturn V and be reusable. Musk has thought about this a lot, obviously. The point at which one says the goal is to make life multiplanetary, it means that we need to have a self-sustaining city on Mars, Musk said. That city has to survive if the resupply ships stop coming from Earth for any reason whatsoever. Doesn't matter why. If those resupply ships stop coming, does the city die out or not? In order to make something self-sustaining, you can't be missing anything. You must have all the ingredients. It can't be like, well, this thing's self-sustaining except for this one little thing that we don't have. It can't be. That's like saying, well, we went this long on a sea voyage and we had everything except vitamin C. Okay, great. Now you're going to get scurvy and die. And painfully, by the way. It's going to suck. You're going to die slowly and painfully for lack of vitamin C. So we got to make sure that we got vitamin C there on Mars. Then it's like, okay, rough order of magnitude. What kind of tonnage do you need to make it self-sustaining? It's probably not less than 1 million tons. That's all for today's episode. Thanks so much for watching and see you next time.